Intelligent agents are the next topic of this course, which is the main unifying theme of the artificial intelligence. We define artificial intelligence as the study of agents that perceive the environment and perform actions in the environment. So in this class, we are going to cover chapter 2 from the artificial intelligence, a modern approach, which is our textbook of the course. We are going to examine agents. We are going to examine the environments and the coupling between them. So some agents and some agent architectures might be more efficient than the others. And this naturally leads to the idea of a rational agent. So we are going to speak about rational agents, which we have seen in the definition of the artificial intelligence. One of the definitions related to the rational acting had to do with the concept of rational agent. We are going to see also different kinds of environments. Some environments are more difficult than the others. We're going to give a categorization of environments and show how properties of an environment influence the design of agents for that specific environment. And we are going to describe a number of basic agent designs. So what is a software agent? To respond to this question, we are going to first try to respond to the question, what is an agent? So here you see an agent 007. You must have seen a video or a movie related with an agent 007. And as you know, his actions are basically he always chooses the best possible action in each situation. So related to this concept of an agent, we are going to deal with intelligent agents, and intelligent agents are supposed also as the agent 007 to take the best possible action in each situation. So we're going to study the problem of building such agents that are intelligent in this sense. Now, the definition of the word agent as an adjective, it might be one that acts or exerts power, or as a noun, a person who acts on behalf of another person or group, or a person or thing that takes an active role or produces a specified effect. Now we're going to use the concept of software agent as a computational metaphor of artificial intelligence. And in this concrete context, the intelligent agent will be a computational entity that has some degree of autonomy. And when we speak autonomy, we speak about three main concepts: reactivity, proactivity, and sociability. Reactivity is related with the capacity to respond to the changes in the environment. Proactivity is related with the capacity to exhibit a behavior directed towards accomplishing its objectives. And sociability is related with the capacity to communicate and collaborate with other agents and within its environment. Therefore, an agent can perceive its environment by its sensors, as you can see on the image down to the left. It can assign perceptions to actions through some kind of an agent function. It can act in the environment by its effectuators, and then it can also measure how well it has done in respect to what it aims to do. So there are various motivations for developing agent technology and applying software agent technology in the real world. The most famous example is internet, where basically agents are almost everywhere. Usually the characteristics of the systems where you are going to apply software agent technologies are large scale, complex and distributed systems, where basically you have different decision makers with different points of view and different preferences. Then these are usually open and heterogeneous systems that are built usually independently. The examples of open systems are the systems where the users can enter the system and leave the system at their own will. And heterogeneous systems basically means that there are different kinds of users or different kinds of components that construct and make these systems. Then you're going to use agents also in the distribution of resources. So basically, if you have a limited amount of resources, how to distribute them is a question of intelligent agents. Distribution of expertise, you can consider also expertise as a resource. In the case of personalization and customization, in the case of interoperability of pre-existing systems, and integration of legacy systems, the systems that have been used previously before agent technologies. We distinguish between two kinds of artificial agents. The first one are hardware agents or robots, and then there are software agents or software robots or softbots. So the hardware agents or robots act directly in the physical environment. Their sensors are well-known: cameras, lidars, odometers, etc. They have actuators, wheels, grippers, mechanic arms, etc. While the software bots or softbots or software agents work in virtual environments. So as we said before, in internet, and their sensors and actuators depend on the case in which they are. Previously, we have mentioned some areas connected with artificial intelligence. Now, areas connected with agents and with software agents in specifics, in research and theory of artificial intelligence, we speak about object-oriented programming, distributed systems and distributed architectures. Economy, we take concepts from auctions, we have take concepts from markets usually, because these are self-interested agents applicable to competitive environments. The concepts of sociology, the concepts of psychology, decision theory, biology, and many others. You're going to find artificial intelligence software agents in many different fields today. So most of them are found in internet. You're going to find them in information systems, in e-commerce, when you use your user interfaces on your smartphones or your computers, in transport, especially intelligent transportation systems, in intelligent networks, in smart nets, on smart grids of energy. You're going to find them in robotics and production. Usually robots are designed as agents, but also they are designed in multi-agent systems where different parts of robots are different agents and they interact with one another. You are going to use them also in simulation whenever you need to simulate an environment where you have multiple entities acting independently, and you're going to use them, and you use them already in games. Okay, so let's review what we have said so far. So an agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Now we can have a human also programmed as a software agent. Okay, so imagine that you had this incredible computer capacity to model it, then you would basically say that the eyes, ears, and other organs of the human are basically human sensors, and you have actuators such as hands, legs, mouth, and other body parts. And then In robot agents, you have cameras and infrared range finders for sensors, various motors for actuators, as we have mentioned previously. Each such agent will implement a function that maps percept sequences to actions. So we will cover different kinds of these functions. And basically, we are going to distinguish between reactive agents, real-time planners, and decision theoretic systems. So while an agent function maps percept histories to actions, an agent program runs on the physical architecture to produce this function. So an agent is a combination of an architecture and a program. Let's have an example of the vacuum cleaner world. So on this image, you basically see a robot vacuum cleaner that can move from one room to other. There are two rooms, A and B, and there is a dirt present or not in each room. Now, the robot can perceive the location and the state of the environment. So, for example, we can say that the robot is in room A and the room A is dirty, or the robot is in room B and room B is clean, or it can be any combination of these. So A clean, A dirty, B clean, B dirty. The robot has at its disposal 4 different actions. So it can move left, it can move right, it can vacuum clean, so basically it can clean the dirt that is present in the room it is in, and it can have no operation. How can we make that this robot cleans all the rooms? Let's see how these concepts reflect to this exact case that we have in front of us. Robot is found in room A, and room A is dirty, and it needs to clean the dirt from room A and room B. Under the image of the robot with the dirt in the rooms, we have the architecture of an agent. So it has its sensors. Sensors are connected with the actions through the actuators through some kind of a function, agent function that we are going to see right now. Then the agent is in the environment. In the environment, what it can perform the 4 actions that we have spoken about before. So vacuum clean, move left, move right, and no action. So at the momentary stage, the agent is going to read through its sensors that it is positioned in room A and if the room A is dirty. Therefore, it is going to apply through its actuators vacuum clean action. The agent program usually works in iterations. So after it has vacuum cleaned, it is again going to read through its sensors its position. So basically it is still in room A and room A is clean right now. Therefore, the situation is going to, its decision-making module, it's going to make it, or agent function is going to make it move to room B. It's going, so it basically its connection between agent architecture and the environment is going to be moved to move right. Then its sensors are going to read again. So its sensor in a new iteration, its sensors are going to say you are now in room B and room B is dirty. Its agent function should now give connection between this reading and the actuators vacuum clean. So the actuators will vacuum clean in the environment, and that is in room B dirty. The action vacuum clean is going to make disappear the dirt from room B. Therefore, in a new reading, it's going to have, sensors are going to read that room B is clean. And basically, if it has a history, so if it has a history of the plan, all the plan that it was supposed to do, and the actions that were performed to execute all the things that it had to do, then it will just, in the new iteration, it will move, it will just stop, it will do no operation. For each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure. And this should be based on the evidence provided by the percept sequence and the built-in knowledge the agent has. Now here we are using the word performance and word measure. So what is the performance measure? So it is some kind of an objective criterion for success of an agent behavior. Let's give an example of the vacuum cleaner agent that we saw before. So in this case, it would be the amount of dirt cleaned up, or the amount of time taken to clean up all the dirt, or the amount of electricity consumed, or the amount of noise generated, etc., etc. So this is all on the decision of the designer of the system. So the designer of the system decides which are going to be performance measure or key performance indicators. Let's clarify some concepts when we speak about software agents. The first one is the concept of rationality. So the concept of rationality is distinct from omniscience, that is all-knowing with infinite knowledge. So rationality is basically, given the information that the agent has, it decides the best possible direction of action. Agents do not have to perform all the actions to execute the tasks that are given to them. They can also perform actions to modify future percepts so as to obtain useful information. So they can go gather information, they can go explore the environment, and so on. An agent is said to be autonomous if its behavior is determined by its own percepts and experience. So an agent can have also the ability to learn and adapt without depending solely on built-in knowledge. But however, an autonomous agent does not depend on any other entity or environment to make the decisions for it. Previously, we have said that the agent type, some agent types will be more or less efficient given the environment. So before we design an intelligent agent, we define and specify its task environment by the PEAS method. And the PEAS method stands for, P stands for performance measure, E stands for environment, A stands for actuators, and S stands for sensors. Let's give an example of a taxi driver seen as an agent. So a software agent representing taxi driver may have different kinds of performance measure that is given by the system designer, as we said before. So we might want to have a safe drive, a fast drive, fuel efficient drive, a legal drive, comfortable trip. We want to maximize profits, and so on, so on, so on. Minimize costs, and so on. So we can have a point of view of the user of the taxi driver, so basically the client, or from the point of view of the taxi driver as well. The environment in which the taxi driver performs its service are roads, transportation systems in general, or infrastructure. But then you have it interacts with other traffic, with other vehicles on the roads. It interacts with pedestrians, it interacts with its customers, and so on and so on. The actuators that the taxi driver has at disposal are the steering wheel, accelerator, brake, signal, horn, some kind of communication system, and so on. Regarding the sensors, um, its sensors are cameras, sonar, speedometer, GPS, odometer, NG sensors, keyboard, and basically any kind of a device that can give him or her information about the driving conditions. Now let's see a new example of the piece method in case of part picking robot. A part picking robot is a robot, usually fixed one, without a mobile platform on which it stands. So it's on a fixed platform that works in front of a conveyor belt with some parts to pick and with bins where these parts should be put into. Usually different bins are specialized for different kinds of the parts. So you should put a specific part to a specific bin. So a performance measure of this kind of the system can be a percentage of parts in correct bins. Environment is, as we said before, you have a conveyor belt that brings all these parts and the bins where the parts should be put. Actuators are or one or two joint arms and gripper. And sensors can be camera, joint angle sensors, and so on. Now, I'm going to leave to you the example of medical diagnosis system. Let's think now, how would you apply the PEACE method to the medical diagnosis system? And here's the solution. So your performance measure is that basically your patient gets healthy. You want also to minimize costs. You want to minimize lawsuits and things, similar things. Your environment is your patient, hospital, and the medical staff. Actuators are all the possible actuators you can have at the disposal of medical diagnosis system. So screen display, questions, tests, diagnosis, treatments, referrals, and so on. And your sensors are, well, usually your keyboard, your mouse, and your symptoms, findings, patient's answers, and so on.